Hi, hello everyone. Today we are going to see about the observed linear system x dot equal to a t of x, y equal to h of t of x is said to be observable if there are distant points up to s1 to sk belongs to 0 comma t such that the rank v of s1 s2 up to v of s1 s2 sk comma 0 equal to n, which means the rank of v equal to n, where v of s1 where the v of s1 s2 sk comma 0 denotes nothing but h of s1 x of s1 comma 0. So what we do means, if the system is said to be observable, then the rank equal to n. Okay, for that we know that the linear algebra that v star v always greater than or equal to greater than 0, because it's a positive definite, it's a quadratic form. So let us assume the rank. For that we assume the rank v in n such that k distant points occur in the interval 0 comma t. We assume that the rank of v is n and there are the k distant points in the interval 0 comma t. For that we know that v star v greater than 0. So the v star up to how many points? If it is 2 means v star of s1 comma s2 comma 0. So it is a k distant point. So v star of s1 s2 to sk comma 0 and v of s1 sk to 0. So we know that v star can be represented as h of s1 x of s1 comma 0. For that it is a conjugate. So it's a star nothing but is a transpose. So it is in the row form, so we are taken in the column. It is in the column, so it is taken in the row. So x star of it is denoted as star, so x star of s comma 0, h star of s1 and x star of s2 comma 0, h star of s2 up to x star of h star of sk. Okay, then v of s1 is nothing but this term. So v star v is nothing but summation terms of all these terms. So x star of si 0, h star of si, h of si, x of si comma 0. So we choose some delta that is greater than 0, and delta can be written as delta is between, here it is 0 to t the interval, here is s1 s2 up to sk. So the distance between the point is del. So which is del less than or equal to 1 by 2 minimum of del si minus, it is s1 s2 s1 s2 is 1 by 2 minimum of s1 minus s2 for I not equal to j. We consider there exists some positive distance, so plus or minus is used to denote the si lie, that means the one term. So it is a delta distance is up 0 to, which is si, and s2 is comparatively, if it is del means it is sk plus del, here sk plus del, and it is s1 minus del, because up to 0 to t there is some form value, that is del value. So it is plus or minus. So the if we take the whole interval 0 comma t means there is si plus or minus some del. So now we take w of 0 comma t is 0 to t x star of s comma 0, h star of s, the h of s, x of s comma 0. So it is always greater than or equal to, it is a one term but it is greater than or equal to whole the summation term. So up to which point means si to si si plus del. Okay, si plus del terms. Okay, greater than or equal to this terms. So we know that h star of this term is nothing but summation of all these terms is nothing but v star v. So v star v into the si plus or minus del. So if we integrate means we get si plus or minus del minus si, so getting cancelled. So del into v star v plus order of delta. So it is w of 0 comma t is greater than or equal to v star v delta plus order of delta. So order of t delta represent the matrix r of delta such that if the limit delta tends to 0 means r of t of delta, that the matrix form also tends to 0. So if the delta tends to 0 means the matrix terms also tends to 0, and W of 0 comma t is usually greater than or equal to V star V of delta plus order of delta. So we assume that V is n. Okay. So if the result of V equal to n, then V star V is usually greater than 0, because it is n means it is n linearly independent, which the matrix is equal to n means it must be a positive, so it is greater than 0. So implies that delta is sufficiently small, whatever the delta is sufficiently small, but it must be greater than 0. Okay. So V star V, we have V star V delta plus order of delta greater than 0, which is nothing but W of 0 comma t also implies W of 0 comma t is greater than or equal to this term. So this term, instead of this term, we replace W of 0 comma t, that is also greater than 0. So we take that the system is observable based on the observability condition of based on the, which means if we take the rank equal to n and we have proved there exists a positive definite matrix. So we usually know if we have to prove the system is observable means there is a n number of ways to prove the system is observed. Based on the condition here, if we using the matrix, which means positive definite matrix, so the system is observable. We get the positive definite matrix, so the system is observable. Hope you all understand, and thank you.